In this video, I'll try to show you how to solve relatively easy circuits. These would be circuits that only have one loop and one battery in them. So imagine you're given a circuit like this. 10-volt battery here, 1 ohm here, 2 ohms here, and 3 ohms here. Notice that these two are in parallel. And the question might be asking something like, what's the current through the 3 ohm resistor? So that would be I3. How do we solve that? So here are the steps down below. I'm going to take you through them. Briefly, first thing you have to do is find the total equivalent resistance of all these three resistors. And once you get that, so that's step number one, then what you can do is you can find the current that's going through this loop like that. And that'll be the current that's basically going through the 1 ohm resistor. I know that's not the direct answer that you want to get, but you need to get that in order to get to this current here that's going to go there. Next, what you want to do is find the voltage drop across the 3 ohm resistor. If you know the current going through the 1 ohm resistor, you know how much the voltage drops there, and then you can find out how much the voltage drop here will be. Once you know that voltage drop, then you can use V equals IR to get the current that's going through it, because you'll know the voltage and you'll know the resistance. Okay, let's begin. So let's find the total equivalent resistance. So here's the original circuit right here. And what we want to do is basically simplify first this part that has the parallel resistors and get an equivalent resistance there. And then after that, we want to sum these two resistors together, the 1 ohm and the equivalent resistance of the parallel, to get one total resistance like that. And once you get that, then you can get the current that's going around this hoop like that. And that's going to be an important step. So let's proceed. Let's try to figure out what the equivalent resistance is of these two resistors in parallel. Now the formula for that is basically 1 over the equivalent resistance equals 1 over the first resistor plus 1 over the second resistor. And in this case, the first resistor is 2 ohms, the second one is 3 ohms. Now you just can't add these things like that. What you have to do is get a common denominator. In other words, the part on below of the fraction, below the fraction line there, has to be the same for both this fraction and that fraction. There's no common denominator between 2 and 3 because they're such small prime numbers, but the product of 2 times 3, 6, could be a common denominator. How can we get there? Well, if I multiply 2 by 3, I'll get 6, and if I multiply 3 by 2, I'll get 6. So what I'm going to do is take this fraction here, 1 over 2 ohms, and multiply it by 3 over 3. I'm allowed to do that because I'm just multiplying it by 1, and 1 doesn't actually change the value, but it will change the form of this. So 3 times 2 ohms is going to give 6 ohms downstairs, and then 3 times 1 is going to give 3 upstairs. Likewise, I'm going to multiply this fraction by 2 over 2. That will give me 6 ohms downstairs, and then 2 upstairs. So now it's transformed into this equation here. 1 over the equivalent resistance equals 3 over 6 ohms and 2 over 6 ohms. Now, because they have a common denominator, I can add them. So 1 over the equivalent resistance, that's this, is basically going to equal 3 plus 2 over 6. Now, don't forget to flip this. You might say, oh, it's going to be 5 over 6 ohms, and that's my answer for the equivalent resistance. No, remember, this equivalent resistance is 1 over in that formula. I've got to flip it, and I've got to flip that too. So the equivalent resistance is 6 over 5, 6 ohms over 5, which is going to be 1.2. And notice that that equivalent resistance, which will go here, is lower than the resistance of either one of these. So when you put things in parallel, the resistance goes down. Okay, so we've accomplished the first step, which is to find this resistance here. Now we're going to basically combine that with this 1 ohm to get the total. So I still want to find the total equivalent resistance. What we just found in the previous page was that this was 6 ohms over 5, and I've got 1. Now these guys are in series, and if they're in series, what we do is we just add them straight up like that. So the total resistance of these two is just going to be 1 ohm plus 6 ohms over 5. Again, I want a common denominator like that, or you could just punch it into your calculator and go, that's 1 and that's 1.2, and you'll add it, that's fine. Or you can get a common denominator by basically multiplying this by 5 over 5. So now I've got 5 ohms over 5. That's still equivalent to 1 ohm, which is what we had before. So 5 ohms over 5 plus 6 ohms over 5. That's going to give me 11 ohms over 5. That's the total resistance that goes right in that spot there. And here's our circuit. Okay. Now I know the voltage. The voltage is 10 volts, and I know the resistance here like that, 11 ohms over 5. Now we can go to step 2. Step 2 is to find the current through the 1 ohm resistor. So here's our circuit. It looks like this. I've got a battery that's pumping things. This current is going around like that, and it's going to flow through this equivalent resistor of 11 ohms over 5. But guess what? That current that leaves the battery and goes through the first resistor is exactly the same current that's going to flow in this circuit. Okay? So what I can do is I can basically say the total voltage is 10 volts. The total resistance is 11 over 5, and now I can solve that for current. Okay, so V divided by R is going to give me I. So that's going to be 10 volts divided by 11 ohms over 5. Now, dividing by a fraction is the same as multiplying by its reciprocal. So here I have 10 volts over 1. That's a fraction. And I multiply it by 5 over 11 ohms, like that. So 10 times 5 is 50. And 11 times 1 is just 11. So I've got 50 volts over 11 ohms. That's 4.55 amps. So that's the current that's going around and around in this circuit right here. All right? Now let's find the current going through the 1 ohm resistor. Well, that's it. It's 4.55 amps. It goes right through there. It goes all the way down and back. Now, if I zoom back out to look at the entire complete circuit, now, remember, it started with this. I had this 1 ohm resistor here. Then I had these 2 ohms, or these 2 resistors in parallel here. What's going to happen is the 4.55 amps is going to go right through that, and then it's going to get to these two, and it's going to split. It's going to split in some way. And we're going to try to figure that out, and part of it is going to go over the 3 ohm resistor. That's the I3 component. Let's take a look at this. So to figure out what that is, we're going to have to figure out what the voltage drop is across the I3 resistor. How do I know what that is? Well, you can look at the whole loop voltage thing and say we start out at 0 volts, we go up to 10 volts when we traverse the battery in this direction. And now as 4.55 amps is going to flow across the 1 ohm resistor, the voltage is going to drop. If we knew how much it dropped by, then we could figure out what the voltage was at the beginning of the 3 ohm resistor right there. So if I know it's 10 volts right along here, okay, because that's connected to the top of the battery, it drops a certain amount, and then by the time it gets to the 3 ohm resistor, it's at that new value that's dropped. If I know what that is, then I can find the difference across these guys. Do I know the voltage at the back end of the 3 ohm? Yes, I do, because it's connected to the back end of the battery. There's no other resistance there. It's just straight lines. So that means if the back end of the battery is at 0 volts, then this part right here at that end of the 3 ohm resistor is also got to be 0. So I can try to figure out what that is. But first, what's the drop of voltage across this guy? Well, V equals IR, Ohm's law. That voltage drop is going to equal the current that's flowing through it times the resistance itself. So I times R is going to give me 4.55 volts. So it starts out at 10 volts, and then it drops 4.55 volts right there. So let's zoom in on this diagram just so you can see it. It's 10 volts all the way up to that point right there. Then it drops 4.55 volts. Well, 10 minus 4.55 is 5.45. So right at this point here, it's 5.45 volts. And now that must be the voltage right up to that point on the start of the 3 ohm resistor before it drops. So it drops from 5.45 volts to 0 volts. So the drop across the 3 ohm resistor is 5.45 volts. What can we do with that? Well, if I know the voltage drop and I know the resistance, I can get the current. So let's take a look at it. So here's step 4. Use V equals IR to get I3. Again, we just said that it dropped this amount, 5.45 to 0. And so I can use V equals IR. V divided by R is going to give me the current. So it's drop of 5.45 volts over a 3 ohm resistor. It's 1.82 amps. So that's the current going through this guy right here. Now just to check, let's figure out the current going through the other resistor and see if it all works out fine. Okay? So, as I said, 4.55 amps is going to come here, it's going to go around the bend, and then it's going to split into 2 parts. All right? So what we should get is if I have the same drop of voltage right across here, and we know that's got to be true because these guys are in parallel. So the voltage is the same at the top of this resistor and at the top of that resistor. Likewise, down here, it's at 0 volts and it's at 0 volts. So the drop across the 2 ohm resistor is 5.45 volts also. So remember, this is the 2 ohm resistor. So if I put 5.45 volts divided by 2 ohms, I'm going to get 2.73 amps. So if I have 2.73 amps going through that branch and 1.82 amps going through that branch, does it really add up to 4.55? Put it together, and guess what? It does. And so that means that this seems like we've solved it in the correct way. And hopefully you're able to recapitulate these steps should this appear on an exam. So this involves knowing how to get equivalent resistances for resistors in parallel and resistors in series, and then figuring out what the voltage drop is at a particular point within the circuit. And once you do that, you're able to find the current that goes through it. I hope this was helpful.